Imagine standing on the edge of a mountain staring across a vast expanse of rugged terrain. This isn't just any mountain, it's a block mountain, a geological marvel formed by the immense power of the Earth's tectonic forces. These magnificent formations, aptly named block mountains, are the rising giants of the Earth's crust. The result of millions of years of geological processes, they stand as a testament to the dynamic nature of our planet. Block mountains are significant for more than just their stunning beauty. They provide a window into the Earth's past, revealing the complex interplay of forces that shape our world. From the towering peaks of the Sierra Nevada to the dramatic landscapes of the Basin and Range Province, block mountains captivate us with their grandeur. Join us as we delve into the fascinating world of block mountains, exploring their formation, types, and distinctive features. Ever wondered how these majestic structures come into existence? It's a tale that involves immense tectonic forces and the process of faulting and uplift. Let's unravel this fascinating journey. It all begins beneath the Earth's crust, where molten rock known as magma forms. Over time, this magma cools and solidifies into a new layer of crust. The pressure from the overlying rocks causes this newly formed crust to crack and fracture, leading to the formation of faults. Now, imagine two colossal slabs of the Earth's crust known as tectonic plates, moving past each other along these faults. Sometimes these plates move in opposite directions or one plate slides under the other. This movement is far from smooth and often results in a violent release of energy causing earthquakes. Yet, this seemingly destructive process lays the foundation for the creation of block mountains. The term block mountain is derived from the way these structures are formed. Large blocks of the Earth's crust are uplifted along the faults, while the areas on either side of the block sink or subside. This results in a raised block, flanked by two lowered blocks. The raised block forms what we know as a block mountain. While it's easy to visualize this process as a one-time event, it's important to understand that the formation of block mountains is a slow and gradual process, taking place over millions of years. The tectonic forces responsible for their creation are constantly at work, pushing and pulling the Earth's crust, causing it to crack, fracture, and ultimately form these awe-inspiring structures. This dynamic process of faulting and uplift is a testament to the raw power of nature, sculpting the Earth's crust into stunning landscapes. Each block mountain is a geological masterpiece, embodying the intricate interplay of tectonic forces beneath our feet. Through the colossal dance of tectonic plates, block mountains rise, creating breathtaking landscapes and unique geological features. So next time you marvel at these towering structures, remember the incredible geological processes that have shaped them. Not all block mountains are created equally. They come in different shapes and sizes, each with its own unique characteristics. Let's delve into the various types of these geological wonders. First off, we have the horst and graben structures. Imagine two parallel faults in the Earth's crust. When the block of land between these faults is pushed upwards, we get a horst. Conversely, if that chunk of land drops down, it forms a graben. The Rhine Valley in Germany, that's a classic example of a graben. Next, we have tilted fault blocks. Picture a massive block of rock sliced diagonally like a piece of cake. One side of this block then gets heaved upwards by tectonic forces, creating a steep, sloping mountain. The East African Rift Valley, with its series of tilted fault blocks, is testament to the dramatic beauty of this geological phenomenon. Finally, let's talk about rift valleys. These form when the crust is being pulled apart, causing a block of land to sink down between two diverging pieces of the Earth's crust. The result? A long, flat valley flanked by towering mountains on either side. The Great Rift Valley in Africa is a stunning illustration of this. Now, let's take a quick tour around the world to see some famous block mountain ranges. Starting with the Sierra Nevada in California, these mountains are a spectacular showcase of tilted fault blocks with their sharp, jagged peaks and steeply sloping sides. Heading east, we find ourselves in the Basin and Range Province in the United States. This vast area is a geological wonderland of horst and graben structures, with alternating ranges of towering mountains and flat, sunken basins. From the towering peaks of the Sierra Nevada to the expansive Basin and Range Province, block mountains showcase the incredible diversity of Earth's landscapes. So, next time you're out exploring, take a moment to appreciate these rising giants and the incredible geological forces that shape them. Block mountains are more than just impressive peaks. They are geologically rich landscapes marked by steep cliffs, flat-topped summits, and alternating valleys. Let's dive deeper into the unique characteristics and features of block mountains. One of the most distinctive features of these geological giants is their steep cliffs. These cliffs are a result of vertical faulting, where the blocks of Earth's crust move up or down along the fault lines. This movement creates a dramatic change in elevation, resulting in steep, almost vertical cliff faces that are a hallmark of block mountains. Flat-top summits, or plateaus, are another defining feature of block mountains. These plateaus form when the uplifted blocks remain relatively undisturbed by further tectonic activity. Over time, the forces of erosion level out the top of these blocks, creating a flat surface. This is why you'll often see block mountains with tops as flat as a table. Now let's talk about valleys. Block mountains are often characterized by alternating valleys. These valleys, also known as grabens, form when a block of the Earth's crust drops down between two parallel faults. These lower regions contrast sharply with the towering peaks of the adjacent uplifted blocks, or horsts, creating a striking landscape of alternating highs and lows. But these features don't remain static. Over time, the forces of erosion and weathering work their magic on these landscapes. Rain, wind, ice, and even the pull of gravity gradually wear away at the rocks, shaping and sculpting the mountains. This continuous process can lead to the formation of new features like canyons and gorges, adding yet another layer of complexity to these already intricate landscapes. So, as you can see, block mountains are not just about the height. They're about the story of the Earth's crust, the dance of tectonic plates, and the slow, relentless work of erosion and weathering. These features are the fingerprints of time and tectonics, creating a unique canvas of geological artistry. Now let's take a closer look at some of the world's most impressive block mountain ranges. The Sierra Nevada range in the United States is a prime example of a block mountain formation. Stretching over 400 miles, this range is home to the tallest peak in the contiguous United States, Mount Whitney. The Sierra Nevada is a classic horst, a block of Earth's crust that has been uplifted along faults. This majestic range is a testament to the immense geological forces at play beneath our feet. Venturing across the Atlantic, we encounter the Harz Mountains in Germany. Unlike the Sierra Nevada, the Harz Mountains are a collection of middle mountains, not reaching the dizzying heights of their American counterparts. However, they hold their own unique charm. They are an example of a tilted fault block where one side of the fault has lifted higher than the other, creating a dramatic sloping landscape. But the examples don't stop there. The Basin and Range Province in the United States is a fascinating geological region where block mountains and valleys alternate in a striking pattern. This is a classic example of a graben structure, where blocks of land have dropped down between faults. This has resulted in a series of parallel ridges and valleys stretching across a vast area, from eastern California to western Utah, and even into parts of Mexico. Now imagine the Great Rift Valley, a dramatic scar on the face of Africa, stretching from Lebanon in the north to Mozambique in the south. This is the world's best example of a rift valley, a type of block mountain formation caused by the separation of tectonic plates. The Great Rift Valley is home to some of Africa's highest mountains, including Mount Kilimanjaro and Mount Kenya, both of which are block mountains. From the Sierra Nevada range in the United States to the Harz Mountains in Germany, these mountains stand as testament to the dynamic nature of our planet. These examples showcase the sheer variety and scale of block mountain formations across the world, each one a product of the incredible geological processes that shape our Earth. From their formation to their unique features, block mountains are truly one of Earth's geological wonders. These rising giants stand as a testament to the immense power of tectonic forces, sculpting the Earth's crust into a stunning array of horst and graben structures, tilted fault blocks, and rift valleys. The geological processes behind their formation, primarily faulting and uplift, showcase the dynamic nature of our planet. These processes, fueled by the movement of tectonic plates, have given rise to some of the most magnificent landscapes we see today, from the Sierra Nevada in California to the Harz Mountains in Germany. Understanding these processes not only helps us appreciate these landscapes but also provides insights into the Earth's history and its future. As we delve into the depths of geology, we uncover the secrets of our world and we begin to see our environment in a new light. As we appreciate these rising giants, we're reminded of the dynamic and ever-changing nature of our planet. So next time you're on a hike or just admiring a landscape, remember the immense forces that have shaped the world around us.